All right, I'm starting. This Hangout on Air is live.
All right, can everyone hear me? Hello?
Yes.
You can hear me? All right, can everyone hear me? I hear an echo through someone.
Yes.
You can hear me? All right, can everyone hear me? I hear an echo through someone.
There, I was muted for some reason.
Oh, okay. There's like crazy echo going on.
Yeah, you're hearing the conversation over and over again.
Hi, everyone. Good morning. Welcome to our Hangout on Air session. This week's session is Bootstrapping IoT products with Android and things. Hi, everyone. Good morning. Welcome to our we have with us Dave Smith and Wayne Piekarski. Dave is a developer advocate at Google, focused on IoT and the Android Things platform. Over the past decade, he has worked on low-power M2M systems and wireless radio links, and also built custom applications and system components to run Android and embedded platforms. He has a passion for finding opportunities to make devices and developers smarter. Wayne Piekarski is a developer advocate at Google, focusing on the Internet of Things and the Google Assistant. He has worked for 15 years in academia and industry in the areas of wearable computing, outdoor augmented reality, and mobile devices. He works to get developers excited about new Google technologies through conferences, social media, and training materials. He also works to advocate for developers within Google, ensuring developers have the right tools and information to support their work. We at Google believe that the online identity experience must be improved for users and for developers. In this YouTube live video, we are going to talk about 3 projects we are working on to do just that. And with that, I will turn it over to Dave and Wayne.
All right, thank you. So hello, everyone. Thank you so much for joining us here today. What I'd like to do is just spend a little bit of time here talking about the Android Things platform that we have here at Google and how we see that particular platform helping push the Internet of Things and IoT connectivity forward, and how we can sort of help you as developers try and build better products and make it easier for you to get those products to market. So we're going to talk a little bit about the platform and sort of what it entails, and then hopefully at the end we'll have some time for questions as well, but we'll see how we go. So let's talk a little bit about Android Things. So what is Android Things? Android Things is essentially just a new vertical of Android that is coming into the family alongside Android Wear, Android TV, and Android Auto. So it's essentially just another form factor where we are extending the Android platform, in this case, to be more useful for embedded devices or devices for IoT or the Internet of Things. And the reason that we primarily want to do this is to try and help simplify and accelerate the development of these particular products in order to enable developers in the marketplace to bring these products to production much more easily and much more effectively. And there's a number of different ways that we're trying to do that with the platform that I'm going to go over with you as we're discussing here. So the primary issue here is we want to sort of help developers move from building a prototype and getting that into production. And so there's a couple ways that we like to say that we're helping developers do this. The first is by virtue of the software that we are giving you to run on your embedded devices. So Android Things is a platform, as I mentioned before, that is just an extension of Android for a new form factor. What that means for software developers is that in order to build apps for this platform, you get to use the exact same Android SDK that you are using today to build apps for mobile. And there are a couple differences here and there that we'll talk about a little bit later, but by and large, all of the APIs and all of the frameworks that you're already familiar with in working with Android, you can now use all of that same code to build applications for IoT devices. That also means that you can use all of the tooling that is available to you for all of Android development. So you can use Android Studio to develop, deploy, and debug your applications, and all of the rich debuggers and profiling tools and all of those things that have developed for Android development over time, you can now use those to develop for IoT as well. In addition to that, we also support Google Play services on these devices. And this is actually an interesting thing that I want to step back and just focus on for just a moment. Because if you've been in the embedded space or played around with IoT at all, you may be familiar with the fact that Android is already a very popular operating system for embedded devices. This has been happening really since the introduction of Android, because Android at its core is an open source platform, which allows other developers to take the open source version of it, modify it, change it, and build it for any particular device. However, when they do that, they lose out on all of the Google services that are typically integrated with mobile devices that developers have become so familiar with and used to using. So when we talk about Android and embedded up before Android Things, it meant that you were developing with the Android SDK, but you didn't have the benefit of Google Play services. With Android Things, this is a fully supported version of Android from Google. So not only do you get to develop Android apps, you get to develop Android apps using Google Play services and all of the other Google services that you're already familiar with connecting to your mobile apps, such as the Firebase platform or the Google Cloud platform. So that greatly accelerates what you can do not only on the device, but also in terms of getting that device connected out to other services. But we want to build more in this platform than just allowing you to run Android on some new embedded device. Like that is a great thing, and it helps you build great applications, but there's more to embedded and IoT and building real products that we have to sort of look at. And one of the biggest issues around this is not just building the app, but once you've built this app and you've developed this new device to ship to consumers, how are you going to maintain that thing? So in addition to actually building the software, at some point you're going to want to update it. Or from the perspective of the platform, there may be security patches or other things that you need to get into the device out in the field after it's been sold and after you no longer have the ability to touch it directly. So with Android Mobile, we enabled developers to do this sort of thing using the Play Store, right? It was a mechanism that allowed them to develop an application, distribute it to multiple devices, and then when they had an update, they could upload that new version, and the Google Play Store mechanism would update all of the users' devices that had that application on it. We want to take that same concept and translate it now to enabling developers to actually build their own devices. And so what we've provided as part of Android Things is what we call the Android Things console. And so the console is, I have a screenshot of it shown here, but this is a web portal that you can interact with. And you could kind of think of it like the Play Store for Android and IoT, where it's a place where you can build a definition of whatever the product is that you're building. And you can download software images for that particular hardware to get started during development. But then beyond that, when you have applications that you want to ship to devices in the field, you can upload those applications to the console, and we will take the responsibility of packaging those up into over-the-air updates that can be shipped out to each one of those individual devices. Now, one of the interesting differences here between Android Mobile and what we're doing on Android Things is that when you ship an APK to a new version of an APK to users on an Android mobile device, that specific application is actually being downloaded to the device and an update is being applied. With Android Things, we're actually applying full operating system updates to these devices the same way that you would get an OTA update from your carrier or from your device manufacturer on your Android phone. We're using the exact same infrastructure that we use to deliver those OTA updates to all of those devices today. But we're now opening it up to developers so that you can provide the apps and changes that you'd like in your specific device. And then we can push those device images down to everything that you have out in the field to ensure that those devices remain secure and up to date. So the console gives you an interface where you can interact with the devices and you can push updates out to them in the field. And this is important to keep in mind because this idea of staying in touch with your devices is a very important point for dealing with IoT. Primarily, if for no other reason than from a security perspective, right? There's been a lot of recent devices in the IoT space in the news lately because they were insecure or easy to overtake. And this is creating a lot of issues for consumers. So if you're getting interested in building devices for the IoT space, you need to think very long and hard about how do you secure those devices so that they can get updates to patch vulnerabilities and that the communications with that device can remain secure at all times. And what we want to do with Android Things is basically take the hard work off of your shoulders and maintain it ourselves. So one of the biggest issues around all of that is this idea of producing updates when security vulnerabilities are found in your platform and deploying those to the device. And Google is already doing this for Android on a regular basis. We have a large security team that works on Android, and we already find and fix patches on a regular cadence for Android and consumer devices. What we would like you to do is be able to leverage that same work in the devices that you are building. So with Android Things, we are responsible for managing all of the operating system or framework layers. So when those patches are created for Android, they are also automatically available for Android Things. So that means that if your device is running Android Things, we can make those regular, perhaps monthly security updates to those devices for you in the field so that they always remain with the latest security updates and you don't have to do anything. This also means that we get to leverage all of the security infrastructure that's built into the Android platform in terms of providing images that are signed by Google and verified on the device so that we can ensure that those images have not been tampered with and that the actual code that you wanted deployed to that device is running on the device in the field. This also helps ensure that the device is always booting into a known good state. through various Android functionalities like the verified boot architecture. And we also have this functionality known as AB rollback protection, which essentially allows us to deploy an update to the device, verify that it's a known good update, and then ensure that the system is capable of booting into that new version of the operating system. If anything goes wrong along that path, we can automatically roll back to the previous known good version of the operating system at any time. So we ensure that we can apply these updates securely and in the background, and we ensure that the devices can always boot into a known good state so that you're not bricking devices in the field just because of a bad update or even something that may have happened improperly in the application update that you're deploying. So we take the responsibility for the framework and the operating system, and you take the responsibility simply for developing the application pieces that are specific to the device that you want to build. All right, so that sort of covers software on the device, as well as some of the tooling and deployment mechanisms that we're trying to provide to developers around Android things. There's one other piece that I want to describe, though, which is the hardware side of it. So we're now, when we're talking about Android things, we're talking about not just building apps that you deploy to devices that users own. You're actually becoming the device manufacturer. You are building some particular piece of hardware that is running your customized software that you are deploying out to the marketplace. And so there are some things that we think we can do to help make this process easier as well. So what I have up on the slide here are a couple of the hardware platforms that we currently support with Android things. The one on the left-hand side, most of you are probably familiar with. That's the Raspberry Pi 3. And we support this platform for a number of reasons. It's a very common platform. It's inexpensive. It's accessible. A lot of people have these already. And it makes a great starter platform for sort of getting your feet wet with how Android things really works. The hardware is easy to obtain. A lot of people are familiar with it, and there's great community support. So if you're looking at Android things sort of for the first time, and maybe you already have one of these, it can be a great way to get started and play around with it. We have a variety of other hardware platforms that we support, and one of them is on the right, which is the Pico module from NXP. And there's something very specific that I want to point out about this particular module because it goes towards this production story. So if I actually move to a different slide here, you can see something that you may not have been able to see before, which is looking at that particular board. It's actually two individual boards sitting on top of each other, and that's a very important thing. So when you as a developer want to get started with Android things, you would go to your favorite website where you can buy, electronic hardware from, and we have links to various distributors on our website as well where you can purchase these things. But you would pick up what's known as a developer kit, and the developer kit would look like that image sitting up there on the top. What that developer kit actually is two pieces stuck together. The top very small element is what we refer to as a SOM, or a system on module. Sometimes it's also just called a compute module. But it's a very, very small element that has all of the core electronics on it that make up the system. The CPU, the memory, the wireless interfaces, all of the core bits that are essentially running the Android code live on that tiny little module. And then the piece underneath it that comes with the developer kit is just an external board that is designed to break out signals and make it easier for you to work with this module during development. But the end goal of working with a system like this is that eventually when you build your own product, you would reuse the module as a component, and you would build your own version of the baseboard that has just the pieces that are specific to your application. And this has a lot of advantages that I want to talk about, but primarily the idea here is that it simplifies greatly all of the hardware development that you have to do. You still end up having to build some electronics, which for some of you who are completely software engineers, that might be a new concept. And we want to make that as easy as we can. And one of the ways that we're doing that is by abstracting all of the complicated hardware onto this compute module so that the hardware that is built for your application becomes very, very simple and only has the things that are necessary for you. You don't have to reduplicate all of the core elements necessary to build the system. There's a couple reasons for this, and one of them, as I mentioned, is building hardware is actually quite complicated, especially for software engineers. When you're talking about building hardware for some of those core computing components, things like the CPU and RAM, those components are actually quite difficult to lay out if you're not familiar with electrical engineering. And one of the things I want to point out here that sort of underscores this point is if you look at the image that I have up here on the screen, there's a series of these lines running all over the place, and those are essentially just wires connecting the chips together. But if you look at the wires that are down near the HDMI logo, close to sort of the bottom right-hand corner of the image, notice that those lines are not straight like all of the others. They have this sort of odd ladder pattern to them. They're squiggly, and they look very awkward. And it turns out that that is all on purpose. The reason that those things have to look that way is because those signals have a very high frequency, high speed communication. And if that didn't look quite that way, there would get all kinds of electronics interference problems, and the thing just simply wouldn't work. And those are complicated issues that we don't necessarily want you to have to deal with. All of those crazy high-speed routing rules and other things that make electronics difficult to enter into in a lot of cases, we want to abstract those things away from you, and that's why we use the SOM-based architecture, because all of those crazy things live on the module, and the hardware that you would have to build as a base companion for that module is much, much simpler and much easier to learn using basic tutorials if you're not familiar with it, or open source electronics tools that are freely available to anyone. In addition to that, though, when it comes to taking these things to market, one of the other big issues associated with building a product is that if you're going to build a physical product that you're going to ship to consumers, that product has to be certified by various regulatory agencies. So we're in the US, and a couple examples of these are like all of the wireless interfaces have to be certified by the FCC inside of the US. But in addition to that, we have to undergo electrical safety testing for something called UL. And in other countries, there's things like CE for Europe, CSA in Canada. So depending on where you live, there are various regulatory agencies that have to certify your product as safe for consumer use. This type of testing can be very time-consuming, many months, sometimes even years, and can be extremely expensive, on the range of tens or hundreds of thousands of dollars, depending on the amount of testing you have to do. One of the extreme benefits of working with a SOM-based architecture is that that SOM encapsulates almost all of the primary electronics that are in your system, and that module is already certified. So when you buy that as a component that goes in your product design, it means that when you go through certification and testing for your product, all you have to provide to the testing lab is the certificate that says this module is already certified for FCC, CSA, all of that stuff. And that doesn't necessarily mean that you won't have to undergo any testing of your product, but it greatly simplifies that process, making it less expensive and also costing a lot less of your time. And in a lot of cases, like for example, the wireless case, because all of the wireless electronics are integrated onto our SOMs, you probably won't have to go through FCC testing at all. You may only have to go through some basic regulatory testing for your end product. So this reduces your time and cost to market by using this SOM-based approach as well, because of all of the pre-certification work that has been done by the larger manufacturers like Intel and NXP that manage those pieces of hardware. All right, so let me shift gears a little bit now, and we're going to talk a bit more about how this platform looks to developers. So from an Android perspective, some of you may or may not have seen a diagram like this before. Essentially, this is just a stack diagram of what's typically found in an Android device. So you have sort of the low-level pieces of the operating system there, like the kernel and the core libraries, the application framework, which is the layer that as app developers you typically interact with. That's where all your system services are and pieces of the SDK. And then the core applications that live on top of that. These are things that you would typically find in any Android mobile device, right? A launcher app, a phone app, contacts and calendar, settings, all of those sorts of things. So if this is essentially what an Android device typically looks like, this is basically what we've modified Android things to look like. So the majority of the Android framework is still available to you. And I'll talk about some of the differences here in just a moment. But the primary thing that I want you to focus on is the fact that all of the core applications have been removed. So when you're working with Android things, you're not competing with a default launcher or any of these, a settings app or any of these other core applications that are typically user-facing. The only application that is running on the device is your application that you're building. So you essentially have full control over the system, and you're not having to sort of acquiesce or be a good citizen with other applications that the user might also want to have competing for their attention. Now, in terms of the framework, we've made a few minor changes that are primarily around the fact that we don't require displays in Android things. Android things does support the full graphical UI framework, and some of the hardware platforms that we support enable you to connect a display and use views and layouts and all that same stuff the way you would in a traditional Android app. But in some cases, that may not be necessary for your IoT device, and you can reduce cost by not having those things in the system. And in those cases, because display is optional, there are some things that we can't deal with in Android the same way that Android proper does, because it presumes that a graphical display is always there. One of those things that's probably the most common one people notice is the fact that in Android things, we don't support runtime granted permissions. Essentially because there's no way for us to display a dialog to the user and have them grant that back to us. That's just not the type of use case this device is intended for, right? This is a single function, single owned device rather than a consumer device that has apps from multiple places that may have to share user data. So it doesn't really fit the use case of IoT, but in addition, because there's no display necessarily, we can't guarantee that we could even show that dialog. So runtime permissions are not supported in Android things. Android things uses the install time permissions model that was predominant in Android prior to Android M. Another big difference that you'll notice is that in Android, we don't have the system UI functionality. So system UI is the status bar, the navigation buttons, and the other system Chrome that typically wraps the application that you would write for an Android device. All of that has been removed from Android things. So when you write an application and you are using the display, your application window has full control over the entire display. None of that other Chrome gets in the way. There's no home button or back button for the user to try to exit an application. So even if you are using a display for your particular project, you get full control over what that actually means. Now, what we've also done to supplement the Android framework is we've also provided in Android things the things support library. And this is some additional new APIs that allow you to integrate your application more directly with customized hardware. And I'm going to talk about a number of these APIs in a little bit more detail. The two that I'm going to focus on primarily are the Peripheral I/O API and the User Driver APIs. These essentially allow you to write code from your Android app using the same Java APIs you use for everything else, but allow that application to talk to more customized pieces of hardware. So we'll talk about that in a little bit more detail. But before I do that, one thing that I want to mention is that because one of the apps that we removed is the launcher, and because there's not really this idea in Android things of a common launcher where users can manually interact with individual apps, it's essentially just your app running on the system. We've added this functionality such that your application can configure itself to be automatically started on boot. And the way that that's done is by providing us an activity in your application manifest that declares a filter for the IoT launcher intent. And what will happen is inside of Android things, when the system is finished fully booting, it will look for an application that has this intent filter, and it will launch that application automatically as soon as the system is started. So you can write an application that requires no user intervention to get up and running as soon as the device is ready to go. And this is the more common use case that you'll find for these single function devices that you find in embedded or in IoT using Android. All right, so let me talk a little bit more about some of these various APIs. So the Peripheral I/O API, as I mentioned, is a way for you to interact with low-level hardware. So we support various industry standard interfaces such as GPIO, PWM, I2C, I2S, SPI, and UART. Now, if you're familiar with those terms already, then this is making sense. But if you've never heard those before, essentially these are just various interfaces that are used commonly to connect external peripherals to the main system. Common peripherals that use things like I2C and SPI would be sensors like temperature sensors or an accelerometer. GPS modules commonly connect to systems using UARTs. GPIO is basic functionality that you can use to interact things like buttons and LEDs, a custom keyboard matrix perhaps. All of these various peripherals that you might want to connect to your system to define what this custom product is, outside of just a display and a touchscreen or a camera, that functionality needs to be integrated into the system using peripheral I/O. So we've added these APIs so that you can connect that hardware and interact with it using your application. Now, this is often very low-level communication and is probably the most useful, but perhaps not the most approachable when you get into this for the first time. So the next layer of APIs that we've added are what we call the user driver APIs. And we support 4 categories of these today: audio input, sensors, and GPS. Essentially what a user driver is it's a way for you to write some very simple code that takes the data coming off of one of these custom pieces of hardware. We'll use the GPS module, for example, and binding that data into existing framework services. So using the GPS example that I mentioned, a GPS module that you buy from, say, SparkFront or Adafruit or Seed, you could connect that to your device using a UART and then read the data manually off of that peripheral. It comes off in an encoded format that you'd have to parse to determine what the actual location data is. But using a user driver, you can take that data and simply inject it into the Android framework. So rather than having to manually look at all of that raw data, you can simply interact with your GPS hardware using the location manager, or in terms of play services, the Fuse location provider. Right? Those same APIs that you probably are already using in Android, you can interact with new custom hardware using those same things by just adding some user driver code in between the two. So it's all about binding new custom hardware into pre-existing services that are already part of the Android framework. Now, as I mentioned, this may be tricky to figure out as you're getting started. So one of the other things that we've provided, and this is not actually part of the support library, it's something that we have open sourced, it's on our GitHub page, and I'll show you links to that later. But we've provided this open source repository that we call the Peripheral Driver Library. And this is a set of pre-written drivers that use the other previous portions of the API already ready to go for you out of the box. So this is used for common peripherals that you would find through those various electronics distributors like Adafruit and SparkFront or Seed, and allow you to match the piece of hardware that you purchased with a pre-written driver that does all of this work for you. And these are hosted on JCenter, so you can pull them in directly as dependencies into your apps. You don't have to even clone the code and import it. It just works like any other third-party library that you would include in your application code. You can pull down drivers for these various things like temperature sensors, accelerometers, 7-segment displays, and all the other things that we have in that library. And we are adding more drivers to this piece over time. All right, so then just to sort of quickly wrap up the discussion here. So Android Things is really all about helping facilitate, make building devices for embedded and IoT easier for you as developers. So we give you a development environment that allows you to build, I would say, not only just with the power of Android, but really with the power of Google, because we also provide all of Google services available to you to develop for these devices in such a way that all of that is managed and secured by Google. So we're responsible for creating updates, applying security patches, and delivering those things down to the device so that you don't have to have security teams and other teams managing the operating system of your device. You just deal with the app layer the same way that as Android developers you always have. And we ensure that that process happens automatically and securely using the same infrastructure that we use to deploy all of the over-the-air updates to Android devices that we use today and that we've been using for the entire length of Android. Okay, so just a couple final things here. If you want more information about getting started with Android Things, some of the best places to start. The documentation for Android Things is on the Android developer site. So just developer.android.com/things. We have a community on Hackster.io where a lot of our community developers are showcasing really interesting and crazy projects that they are building using Android Things. So it can be a great place for you to go to get inspired about what can you do with the platform, to sort of get some ideas as you're sort of getting started. One thing that I don't have listed here, but I said I would mention, is we also have all of our samples and the driver library are hosted on GitHub. So that is actually github.com/AndroidThings. And you can find all of those resources there as well. And then finally, we have our IoT developers community on Google+, where myself, Wayne, and the other folks on our team are constantly looking at the posts there for people asking questions, people showcasing projects that they've done, and just connecting with each other as well. So it can be a great place to get started, see what other people are doing, and interact with us as well as if you have questions. So that's really all I have to share with you today. Thank you all for your time, and I hope that you're interested to get started and learn more about Android Things.
Awesome. Thank you so much, Dave and Wayne. We have a couple of questions. And folks, you can also use the live chat section in the YouTube video to post your questions as well. So the first question we have is from Eduardo, and he wants to know if you did remove content providers and keep view system, and how do you access SQL Elite without it?
Sure. So there's a couple questions in there. The answer is yes, you can still use all of the View APIs. And if you have a graphical display, all that stuff works the same way. What we removed are the system content providers. So there are content providers on a typical Android device that share user contact information, calendar information, voicemails, SMS messages, all of those things. They're typically intended to provide shared user data across the system. Those default providers are not there, but the content provider API is still fully intact. So if you wanted to use Content Provider API to interact with a SQLite database, you're more than welcome to do that. And of course, the SQLite APIs are completely separate from that, but those are also supported if you wanted to use that directly as well.
Okay, perfect. I have another question from Sai. Are there any Android of Things enterprise applications currently in use which can be used as examples for our clients or other business partners?
Sure, that's a great question. And one thing that I should mention that I didn't point out directly in the presentation is that Android Things is currently in developer preview. We're listed at developer preview 4 right now, and we're going to be releasing developer preview 5 soon. But we're going through a number of preview iterations before we actually get to our first long-term stable, or what we're calling LTS release. And so because Android Things is still in developer preview, what we're currently getting is a lot of feedback from interested developers on how the platform is working for them and how we can sort of change it and make it better. And because of that, we aren't necessarily at the stage of the platform where large enterprise customers are necessarily using it internally in their products. So we're a little bit early days to have those types of projects to show off. But if there are customers who are interested in looking at it for that, we'd love to talk to you about how we could make that happen and see if there are things that we would need to add or modify in the platform to help support those use cases.
All right, cool. I have another question from Amlan, and he wants to know where he can get a Google DIY the Raspberry Pi kit, when beta releases are going live, and is touch input coming?
Okay, so I can answer 2 of those questions, and maybe Wayne can take the third. So as far as the release schedule is concerned, we haven't set dates for exactly when we are planning to land on our first LTS release. But Venkat, who is the head of our group, did have a talk at Google I/O that laid out some of a rough timeline of where we're headed with this. And the goal that he mentioned in that talk was to try and get to LTS around the end of this year. But if you want more details around that, I would go look that talk up on YouTube from Google I/O. It was from just this year, and he can provide more information around that. Regarding touch input is supported as long as the hardware you're using has a touch controller. So for example, the Raspberry Pi display is touch enabled. We have a touch enabled display for the Pico kit as well. And with that hardware connected, touch input already works. There's nothing we have to add to the system to make that happen. As far as the AIY kits, I wonder if Wayne might have an answer to that.
Wayne?
Perhaps he's not online.
Yeah, no, he's online, but I don't think his audio is working too well.
Okay.
Maybe when we can, maybe.
Can you hear me now?
Yeah,
I can hear you.
Okay.
Yeah.
Okay, good. So unfortunately, the AIY projects kits sold out. So we made a whole bunch of them. We gave some away with the Magpie magazine in the UK, but all of them sold out, and that's why people ask us about it. So unfortunately, there's no more available. However, the thing with the kit is that it's based on parts that you can buy yourself. So if you actually look at the diagrams for the AIY projects kit, all the pieces inside are sourced from third parties. You can actually just buy a Raspberry Pi or buy an NXP board and just put the components on top, and you can basically replicate the whole thing yourself. You could even just use like a old USB microphone you've got laying around at home, so you don't need to go out and buy too much. You can basically build it yourself apart from the little cardboard housing. So that's one option if you want to try to do something, is to build it yourself.
Perfect. Thank you, Troy. Sorry, thank you, Wayne. I have a question from Troy, and that is it possible to write or import a custom user driver, and how?
Absolutely. In fact, that's what the APIs are there for, that exact purpose. So the user driver APIs exist for the purpose of enabling developers to write their own, to integrate whatever the custom hardware is that they are trying to build. I want to contrast that with the driver library that I mentioned, because the driver library is really a set of pre-written drivers you can use to integrate particular hardware. But if the hardware you're trying to integrate doesn't have a driver already, the APIs exist in user driver for you to build those yourself. And that's exactly what that purpose is. If you're trying to build drivers for categories of hardware that we don't yet support, in that case, I would ask you to file a feature request or connect with us so that we can see what that category might be, so that we can look at supporting it in the future.
Yeah, one of the cool things about user drivers is that we didn't, the people on our team who wrote those user drivers wrote them just like any other person could do. So we're just giving you examples of how it could be done, but anyone can write one of these, so it's kind of cool.
Mm-hmm.
Perfect. I have two more questions from Anindya. I see support for Raspberry Pi 3. Will Google support any other single board computers? I'm specifically interested to know about hard kernel Odroid line C2 XU4.
Yeah, so I mean, with hardware support for Android things, it requires a very close partnership between Google and the chip maker. So to be supported for the long-term support release in the future, the chip maker has to commit to many years of maintaining the drivers and the infrastructure for their boards. So it would require that manufacturer to say, yes, we're willing to do this for a long time, and work with Google on that. So unfortunately, not everyone is either ready to do that yet, or the other thing is that a lot of this hardware is old and it's already been sold and they've finished it. So for example, we don't support the Raspberry Pi 2 because it's kind of obsolete because version 3 came out. So typically older boards are not going to be supported because the chip makers have moved on. The chip industry moves so quickly that after a year or 6 months even, some of these things become obsolete. So chip makers are only going to commit to certain designs being available for a long time. So that's a factor in what we can and can't support. Now, on the other hand, if you have a board that you really want to support yourself, you can always take Android AOSP and port it over to the board yourself. But now that's no longer a proper Android Things device. So to be Android Things, Google needs to provide the binaries. Google provides the updates. But we can only provide it for a limited range of boards that the manufacturer is really willing to support for many, many years.
And I would also add to that we can't necessarily say exactly which platforms we will support in the future, because even that is changing. But in general, you will probably see us tending towards platforms that are SOM based as opposed to single board computers. That's not to say that we would never add another single board computer, but generally the goal of Android Things is to get developers onto platforms that make it easy to move from prototype to production. And in our view, those are platforms that are based on SOMs. So most of what you'll see coming out of our future support will be SOM-based platforms, most likely.
All right. I've two more for you guys. Bhumesh wants to know, I saw that notifications were removed from the diagrams earlier. Does that mean push notifications, server and local, are removed from the IoT framework?
Good question. No, so the diagram is mentioning the notification service in Android, so notification manager. And really the idea there is that the API actually does work. You could call it, but nothing would happen. And the reason is because there's no system UI anymore. So without system UI, there's no status bar for us to post the notification. And we really don't have plans to provide any customized UI for displaying a notification that's Android things specific. So the API just essentially goes into nothing if you use it. And so we say that technically it's not supported.
Okay. And then I'm in the YouTube link, and there's a couple of questions here. It says, how is Android things different from other IoT platforms?
Well, one of the cool things is that, it's supported by Google. So previously in the past, what people have done is they've taken someone else's operating system, they've made a fork of it, they've made changes, they've rolled it out to their devices, and then 3 weeks later there's a security vulnerability, and then those manufacturers have stopped updating their devices because they either didn't know about the vulnerability or they didn't care about the product anymore or whatever. So one of the big differences that Dave outlined earlier is that Google has the ability to push updates to these IoT devices just like we push to our phones. And so it gives us the ability to update devices even if the manufacturer has stopped updating it or if they've forgotten to update it. And that's the thing, is we're trying to really secure IoT devices to make them so that they can handle security vulnerabilities in the future. And so that's one of the big differentiators of Android things, in that we're really supporting this. And also for our long-term support, we're going to be supporting these SOCs and SOMs for many years. We're going to talk about the length of time later on, but we're going to be supporting these things for a long time, because these devices aren't just that. When you buy an IoT device, it's not just something that you keep for 6 months. You're going to keep it for many years. So we want to make sure that these devices can remain secure for a long time. So that's the big win for using Android things, even compared to just building Android yourself. If you build it yourself, you have to maintain it yourself. And we provide the update mechanism and the OTAs and the testing and sort of the backing of the Android security team to help maintain these updates and bring them to devices for you.
Excellent. Absol wants to know, can we use deep learning libraries with Android of Things?
Yes, I mean, a while ago, I put a blog post out where we actually talked about using TensorFlow. So we had an example where you could use a Raspberry Pi and it had a camera attached, and you could press a button and take a picture of something like a dog, and then it would tell you the kind of dog that it was. And so that used TensorFlow to do that. And so we have a sample that is ready to go. TensorFlow is built and compiled for you to use. And you can just deploy this on your device right now, and you can modify it to do whatever else you want with it. So TensorFlow is very popular. A lot of people are very interested in it. And so we made this sample because we wanted to show people how easy it could be on Android things. And that's one of the things that really, I think, differentiates Android things from other platforms, is that an Android things device is a very powerful device. So, it's got the same computing power as a cell phone. It's not a tiny microcontroller. And so we have the ability to process cameras and audio, and we can do machine learning and sensor processing and all very complicated algorithms that require a very powerful computer. And TensorFlow and machine learning are one of those things. And so that's one of the real big differentiators for Android things. So if you're thinking of building an IoT application that's doing machine learning or TensorFlow, then Android things is definitely a great platform to be looking at. And we've got samples that show you how to do it, and it's really easy.
Excellent. There's one last question in the live chat. I think it's more along guidance. And Kumar wants to know, as a Java developer with no experience in Android development, what would be the ideal learning path for Android things that you would suggest?
That's a good question. So I guess the nice thing about Android things is that it's based on Android, so you can take advantage of all the existing books and learning resources and things like that. Some of my colleagues at Google have actually built like Udacity classes that are like an introduction to Android programming. And so they teach you the basics of activities and services and Android manifests and so forth. And it's very easy to get started. The nice thing about Android things is that you don't need to learn all of the complexities of Android, because you're only using like a subset of it to build IoT devices. And so you don't have to learn all of Android to get started. So I think if you're experienced in Java, then you're going to have a pretty easy time moving over. But definitely, consider getting like an intro book to Android, learn the basics, or take one of these online classes. There's a lot of good material online, and definitely check that out. Dave, do you have any comments?
Yeah, I guess that's kind of where my thought would have gone with it too, is that there are Android Things development is not significantly different from developing for Android. So we're kind of trying to leverage all of the existing resources that already exist there, primarily like the beginning Android, I forget the exact name, but the beginning Android Udacity course that basically just gives you fundamentals. That's what it is, Android fundamentals. That one sort of gives you all of the basics that you need. Without anything deeper than that is probably beyond what you would need to get started with Android Things, but just some of the very intro basics on how Android app architecture works and the basics between activities and services, you can get from a lot of those free resources, and I think the Udacity course is a great one.
And then we also have some good samples as well. So we have a bunch of different samples that blink LEDs or do the TensorFlow example. You can look at that code and sort of work your way around it. But if you want to do a good job, you're going to have to learn a little bit more about Android, because there's a few little gotchas, like, you don't run code on the UI thread and things like that. So, but yeah, those resources are definitely worth checking out.
Excellent, thank you. We have a couple of more questions. I think we have time for those. Shilpa would like to know, how do you block OS level pop-ups in the Android framework?
They're just disabled, aren't they, Dave?
Yeah, I mean, the actual intrinsics of how it's being done is somewhat beyond what I fully understand. But the fact is, yeah, basically all of those that would come up for one reason or another, like permissions dialogues, are essentially just disabled. There's code in there specifically to verify the type of device, and when we're running on Android Things, we circumvent those checks.
Cool. And then one last question from Bhumesh. Most IoT solutions will likely be an always-on kind of scenario. Any best practices or suggestions for maximizing on performance to ensure that we're giving our users the best possible experience ever in the world, galaxy, and universe?
Well, I guess the thing that's interesting about Android Things is it's slightly, I guess it would be easier than a phone, because a phone has a battery that has a finite life. And so, a battery only lasts for a day or something like that. So at least with most IoT devices, they're plugged into power. So I would say it's slightly easier in that you just have to worry about your app running. You don't have to worry about other apps running on the device that might be sucking the power down while you're not looking. So kind of makes it easier in that respect, but you do have to manage what you want to do on the device. If you want to do a lot of processing of images or video streams or whatever, you need to make sure that you fit everything in within the performance of the CPU that you've got. But that's relatively straightforward for you to test locally. I don't know, Dave, do you have anything to add?
Yeah, I guess I would say sort of the same thing, that the best practices that exist for Android development in terms of using particular APIs to minimize your network access and compute time and things like that are just being good citizens of an Android device anyway for good performance and power management. Reusing those best practices will ensure that you have a good experience on Android Things as well, because the system is even better for you. Because like you said, you're not competing with any other apps. So if you were building your app in the same way defensively using those same APIs and tricks, then your app is going to perform just as well, if not better, on Android Things.
All right, sounds good. And I believe that's the last of the questions. And if you have nothing else, I think we're ready to wrap up the session.
Great, that sounds good. Well, yeah, I mean, if anyone's got any further questions, please join us in our community, g.co/IoTdev. We have lots of people on our team who answer questions there. We want to hear about your ideas, share what kind of crazy projects you're working on. We look forward to hearing about them. And yeah, thanks for everyone for coming.
Yeah, thanks everyone.
Thank you guys. And thank you everyone for watching. Thank you, Dave and Wayne, for your time. Bye-bye.
Thank you, bye.